Now if L is the value of the limit as x tends to 0 for cos 4x plus a cos 2x plus b by x to the power of 4, and this value of L is given to be a finite number, then find the values of a, b and L, right? One common procedure of solving this problem is, as x tends to 0, we keep repeating this application of limit by using L'Hospital rule repeatedly till we get a finite values and getting a simultaneous equations in terms of a and b's, and then calculate the value of L for a suitable choice of a and b. But if you look at the denominator, it's being a fourth degree polynomial, so L'Hospital rule becomes a multiple application and becomes a little bit lengthy. So can we avoid L'Hospital rule application here? Yes, that is possible by the use of expansions of cos x. If you remember, the very important expansion of cos x will be 1 minus x square by 2 factorial plus x to the power of 4 by 4 factorial minus x to the power of 6 by 6 factorial plus so on. So if you observe them clearly, there will be alternate plus or minus terms with only even powers of x considered and the denominator being the same factorial. Now when we use this expansion to write the given function, then the problem becomes very simple to solve. Let's see how this expansion would help us to solve this problem. Yes, the value of the limit given L is limit x tends to 0 cos 4x. How will be the expansion of cos 4x by the expansion that we have just now seen? 1 minus 4x square by 2 factorial plus 4x to the power of 4 by 4 factorial minus 4x to the power of 6 by 6 factorial, so on up to infinite terms, plus a times. Now again, how will be the expansion of cos 2x from the given expression? Yes, it would be 1 minus of 2x whole square by 2 factorial plus 2x to the power of 4 by 4 factorial minus 2x to the power of 6 by 6 factorial, so on up to infinite, plus a constant b whole expression divided by x to the power of 4. Now when we collect the terms of similar powers, this limit would now become limit x tends to 0. Yes, collect all the constant terms. There is a 1 from the first term plus a from the second factor and the outside constant b. Then again, how will be the collection of x square factors in the expression? Minus 8 minus 2a times x square. There is a 4 square by 2 factorial here and a minus 2 square by 2 factorial here. So that will give us minus 8 minus 2a times x square. Can you collect the x power 4 factors also? Yes, there will be 4 to the power of 4 by 4 factorial plus a times 2 to the power of 4 by 4 factorial. So that would give us 32 by 3 plus 2a by 3 times x to the power of 4 plus the rest of the factors would be x to the power of 6, x to the power of 8, so on, right? The whole expression divided by x to the power of 4. Now observe this expression very carefully. If this limit has to be finite, as L is given to be a finite number, then we have to avoid the terms which create infinity series here. Now which terms would give us a tendency of infinity? As x tends to 0, the constant by x to the power of 4 factor would give us a infinite term, right? But that cannot be the possible. So constant term should become 0. That means 1 plus a plus b must be 0. Let's treat this as equation 1. Now can there be a presence of x square term? When there is an x square term, that x square by x to the power of 4 would leave us by x square in the denominator. As x tends to 0, that term which is having 1 by x square would again become infinite and the limit will not become a finite number. So even this term must also be exhausted in this. When is it possible? Yes, minus 8 minus 2a should also become 0, right? Now the most important observation. Once there is no constant term and no x square term, observe the next term. 32 by 3 plus 2a by 3 into x to the power of 4 by x to the power of 4. So this factor would be independent of x, right? And all the other factors, this factor would now give x square. As x tends to 0, this part is 0. As x tends to 0, the other part is 0. So what will be left out now? Yes, the value of the limit which is finite would be now 32 by 3 plus 2a by 3, right? This is our third equation. Now we need to calculate a, b and L values all together. So from the second equation, clearly a becomes minus 4. Now when we take this a value and substitute in the equation 1, then from one equation we get the value of b is 3. Now you have a value and b value. What else is required? We need the value of L again. Now L is 32 by 3 plus 2 times, yes, we have calculated a value, minus 4 by 3. That is nothing but 32 minus 8 by 3, 24 by 3, which is equal to 8. Now we have L value, A value and B value. What is the order pair A, B and L? Yes, the value of A is minus 4, the value of B is 3 and the value of L is 8. Let us see which option it is satisfying. Yes, the option presented B, which is minus 4, 3 and 8 is satisfying the value, right?